Okay, right now guys, we're gonna solve for homogeneous differential equation, auxiliary equation in repeated roots. So, we have the equation d to the fourth, that will be 4, and then plus 6d cubed plus 9d squared y is equal to 0. So first thing, we're gonna transform it into auxiliary equation. So we have m to the fourth plus 6m cubed plus 9m squared y is equal to 0. So as what you can observe here, we have as what you can observe there, the exponent of m here is the lowest exponent is squared, so we can factor out the m squared here. So we have m squared times m squared, so we're gonna subtract it by 2. This would become m squared plus 6m cubed minus 2, so 3 minus 2 is 1, so just simply put 6m plus, since we factored out m squared, this would gonna be cancelled, so this should be left with 9. So this would be it. So as what you can observe, we factored out already the m, so m squared would be equal to 0, so this would become 0. So now we have to factored out this quadratic equation. So what is a number that when we multiplied it, it would be 9, and if we add them, they would add up to 6, so that would be positive 3. So we have m plus 3, and then the other one is m plus 3 also, so they are the same. So here you can see that it's m squared, so our m sub 1 would be equal to 0, then the m sub 2 would equal to 0 also, since there the m squared is 0, so wala tayong makuhang other constant number. So here we're gonna equate this m plus 3 to 0, so m plus 3 is equal to 0. So in order to get the m, we're gonna have to transpose it to the other side, so this would become m is equal to negative 3. So the other one also same as what we did here, so this would be m plus 3 is equal to 0, then m is equal to negative 3. So as what you can observe, we have two the same roots here, and also two other roots that are the same. So in repeated roots, we have to use this equation. Y is equals to c sub 1, and then we're gonna have e to the power of m sub 1 x plus c sub 1. If we do have two the same roots, to write that, we're gonna have to add up x here, and then before we write the e to the power of m sub 2 x. So and then if we have like three the same roots, So this would become c sub 1 x. So we're gonna add another x, so this would become x squared e to the power of m3 m sub 3 x. So that's how repeated roots works. So for this equation, our answer would be y is equal to, so this would be c sub 1 e to the power of m sub 1. So our m sub 1 here is 0. So this would be 0 times x plus, then we have a repeated roots here. So as you can observe, they are both the same roots. So this would become, my mistake, this would be c sub 2 and then c sub 3. And then here we have c sub 2. We're gonna add x here because they are in sequence, that is the same roots. So we have to add x here, and then e to the power of our m sub 2 is 0. So this will be 0 times x plus, we have m, since they are not the next the m sub 3 here, and then this will be the m sub 4. M sub 3 here is not the same as the m sub 2, so we're gonna bring back the original form of the term. So we have c sub 3, so be c sub 3 e to the power of, this would be negative 3 times x, then plus, we have m sub 4, so this would be c sub 4, since it is next to the negative 3 here, which is the same value as the m sub 4, so we're gonna add x here, and then e to the power of negative 3 times x. So now we're gonna have the final answer, which is y is equal to, since this is 0, so we're gonna cancel that and we are left with 1. So this would be c sub 1. And then here also we have left with 1, so this would be plus c sub 2 x plus, since here we have negative 3 times x, so this would be c sub 3 e to the power of negative 3 x plus, also here it's just the same, but we're just gonna add x to the center here, so this would become c sub 4 x e to the power of negative 3x. So this would be our final solution for this repeated roots, for this auxiliary equation in repeated roots.